You're watching the last lesson in mechanical systems. In this lesson, we'll be talking about energy, friction, and efficiency. So we'll be talking about how energy is applied in machines, how friction affects machines, and what efficiency is. So when we talked about simple machines, we were talking about things lifting and moving loads, right? Certain things like a lever or a pulley, right? We didn't really talk about the wedge, screw, or inclined plane. We talked about gears and wheels. And so all of these things are examples of simple machines that make it easier to move something. Now, it doesn't reduce the amount of work. It reduces the amount of force you need. So remember, work equals force times distance. Work is measured in joules, force is measured in newtons, and distance is measured in meters. Work shows how energy is transferred and used. As you apply a force over a distance, it does work and transfers it somewhere else. So energy, what is it? Well, energy is the ability to do work. So an example of energy would be mechanical energy, thermal energy, nuclear, chemical, electromagnetic, right? There are many different types of energy, and they can all do work. They can all move something or change something a certain amount. So we will be focusing on two big types of energy, kinetic and potential. The difference is kinetic is the energy of motion, while potential is the stored energy. A good example would be riding your bicycle. As you move your foot around and around and around, like so, you're in motion, you're moving. So that's called kinetic energy. And that energy is applied over a distance on this sprocket, if you remember that, to the gears and cause the wheels to spin. So that's kinetic energy. Stored energy, or potential energy, is the energy that the machine or object or person potentially has. In this case, we have a bow. When you pull the bowstring back, it bends backwards here and here, and it holds onto this arrow, and what's happening is until you let go, it has this potential to release this energy. Until you do, it's just called potential energy. Another example is, as you pedal a bicycle, you apply kinetic energy to the pedal. You're moving it. The pedal uses that energy to move the bike through its sprockets. When you reach the top of the hill, let's say you stop. Well, you now have potential energy. You now have the potential to move down. And when you go down, that potential energy is then converted to kinetic energy. Potential is the maybe. This is how much energy you could have, but you're not using it yet because you're at top of the hill. You're not going down yet. Once you start going down, that's your potential energy turning into your kinetic energy. So for a machine to do work, how much work needs to be put in? This is just a review from our earlier lessons, because you need to know that work in must equal work out. In levers, we talked about this. The amount of work done by the machine or the load has to equal the amount of work you put in. Machines don't lower the amount of work. Machines lower the amount of force you need. So this is only true when there is no friction. This is an ideal situation. So since the beginning, I've sort of been lying because the work in should equal the work out, but that's only if you're in perfect conditions. And as we all know, life isn't perfect. And so we have something called friction. What's friction? Friction is the resistance to motion. Friction converts some of the energy used into heat. An example is rubbing your hands together. If you rub your hands together very, very fast, you'll start to feel it. If you do that right now, if you rub your hands together really, really fast, you'll start to feel heat. You'll start to feel warm. And that's because the energy you're putting into your hands as you're moving them back and forth is creating friction. And the energy you're putting in is being converted into heat. And so you're generating heat. And so some of your energy actually isn't being used to move your hand back and forth. It's actually that some of that energy is being lost in terms of heat energy. So when friction is involved, more work needs to be applied. So when we talked about work in equaling work out, that's ideal. That's if there was no friction. But because there is friction, you need to do a little bit more work to move the object. Work in needs to be a little bit bigger to make up for a loss in energy because of friction. So this video will talk about what friction does to the energy we put in, but we now know that energy will always be lost because of friction. You always lose some energy. It's never perfect. So we call this efficiency, right? How good is a machine at reducing friction? We call this efficiency because we want to talk about, well, how is that machine reducing the amount of friction? How is that machine getting over this friction? Do you need just more energy? Well, that's not very good. You want a machine to use as little energy as possible, right? So we use efficiency to describe when something is good at reducing the amount of friction and using the energy for its intended purpose. So efficiency is used to calculate how much energy or work is being used by the machine. It can be found by taking work out, the amount of work put out by the machine, and dividing it by the amount of energy or work put into the machine. That gives you a decimal. You multiply that by 100 and you'll get a percent. And so we can say something is a certain amount of percent efficient. So let's say the amount of work you put in was, or amount of work put out was about 50 joules of work was put in. And the amount I put out, and the amount of work you put in was about 100 joules. Well, you divide them up, you will get 0.5, right? Times it by 100, well then that'll give you 50%. So you'd say that it's 50% efficient. Now you may say, well that's not good. I just lost 50% of my work. What's the point of that? Well, most machines aren't actually that efficient. So if we say a machine is 5% efficient, that means that only 5% of the energy, the work that's being put into that machine or that object is being used properly. You're saying that only 5% of the energy you put in is being used properly. Well, that's literally how incandescent light bulbs work. These old little light bulbs with these little filaments in the middle, they are 5% efficient. That means 95% of the energy you put into these kinds of light bulbs are just converted into heat. You lose a ton of energy. And so this is an example of this type of science, this understanding showing you how important it is to use your energy well. And this is why these types of bulbs are going out of style. So how can we increase efficiency? Well, decreasing the amount of friction naturally, right? If you decrease the friction, you decrease the wasted heat, so you can use more energy for your job. Well, how can we do that? Well, we can do that by using oils, right? We can use oils, right? We can use smoother parts, right? Smoother parts, right? We can use different types of things to reduce the amount of friction so that things slide past each other. And that's one of the biggest things in science, in engineering, in designing, is to reduce the amount of friction, that is required to have a machine do its job. And so decreasing the amount of friction is a way to decrease or increase the efficiency of a machine. And that's literally some people's job, making things more efficient, making sure energy isn't wasted. And this is applied in every field, from cars to other types of engineering, to power production, and so on. And so this is very important to everyday life. Hopefully this was useful, and I'll see you next lesson.